In this video, let's take a look at the problem Calf Flac. So we're basically given a super long string, and we need to find the longest palindrome in the string if we ignored all of the characters that are not inside the alphabet. And also, we should only look at the same, so we can ignore the cases and also white spaces and punctuations. And also, we can ignore numbers. So we can basically use get line multiple times to reading all of the lines because there can be multiple lines inside these. And between every line, we should append the /n as well, basically appending a new line, because we should also print that out at the end when we are printing out the final answer. And so we can basically look through each of these letters and think of this letter as the center of the palindrome. For example, let's say we're looking at this I. Then we will think of this as the center of the palindrome, and there can be palindromes extending outward from these two directions. And so the way we can do that is there might be two possible ways. The first way is if we think of this. So if the palindrome has an even number of letters, for example, let's erase the test, and then we can see maybe 1, 2, 3, 4, 4, 3, 2, 1. Although this won't happen here, so we could use the characters instead. So this, if we think of this, there's no center here, because if there's a center, then this palindrome will be having an odd number of letters. So here it's an even number of letters in this palindrome. So we could think of this as the center for one end, and we look at the next letter like so, and then go on. So there are two cases. One is when we think of this as the only center, then we'll look at the two from the other two sides. Otherwise, we would think of this as one side of the center. Then there will be two centers, basically these two letters, and we should compare these sides, these two sides, instead of skipping this current letter that we're looking at. So here's basically the code. It's actually very simple. We just barely any algorithms in this problem. So first we'll get line and then add it into our total string. Also add a new line every time at the end. Then we will look through the whole string. Out here, we'll store the maximum length of this string. At first, I'll just set it to 1 because we can always get it later. And here, we will check the two lowercase and two uppercase. Both convert these to lowercase, convert the two letters that we're convert the current letter that we're looking at to lowercase. And if it's outside of this range from A to Z, this means that it's not one of the letters inside the alphabet, so we should skip this current letter and look at the next one. So if it is inside the alphabet, so this current letter is inside the alphabet, we will try the two cases. One is when we are thinking of this as so this is when we think of it as the center, when we think of this current letter as the center, and we could try what happens if there's an odd number of letters inside this current palindrome. Then we will not look at the letter Si, we will look at Si minus 1 and Si plus 1. So basically skip this middle one. And then I will use the C to count the total number of letters that we have. So first I will set it to 1 because it's just our current letter Si. And then we will store the total length. Basically use L and R to keep track of the total length. Every time we will decrease L by 1 and increase R by 1. So basically, for example, we're looking at this current position. Then at first, this will be our L and this will be our R. So every time we will decrease L by 1 and increase R by 1. So we're basically looking at look at the first letter inside one of the in both of the sides. Then look at the next letter, and we basically can stop when we find a letter that don't match. So this way we will be faster than O1 square time, because if we use the normal way to go through each of the indexes inside the string and then test if there's the longest palindrome in there, then we would run out of time. So here, this will only loop until we reach the longest palindrome available if we think of this current letter SI as the center. So first we'll check if both of the letters at SL and SR are inside the alphabet. I'll also convert them to lowercase because case doesn't matter. And basically if they are, then we should check if they are the same letters. If they are the same letters, we increase our total count of letters by 2 and decrease L by 1 and increase R by 1. And here I'll use this previous value and this current value to store the length of our actual palindrome. And because we can keep on, because otherwise we will stop this program. Because if they're both letters and they don't match, then this means that this palindrome is already the longest possible, so we should stop. Otherwise, we can check if either one of these are not inside the alphabet. So if they're a punctuation, a white space, or a number, then we should skip that current letter that we're looking at. So if the letter on the left side is not inside the alphabet, we should decrease our L by 1. So basically look at the next value, look at the next position. For example, here if we have some random stuff here, then our E will still stay the same when we're looking at this stuff, but then the L will skip all of these letters and look at the next one. So we can compare only the alphabets. And this is the same for the right side. If it's not an alphabet, then we should increase it by 1. And here, this is why we have to get the previous and temp. So basically, this will store the actual length of our palindrome, because we don't want to read any extra spaces. For example, in this, we can look at this as this, but then we can have a bunch of random stuff out here, and then also for this stuff here, we'll also have a bunch of random stuff. But if we already reached the end for these two, L and R, then we'll look at the next two letters. Since both of these two letters are not inside the range of the alphabet, we would increase their pointer again. So now we're looking at the next letter again, and this will make us keep on going until we reach the end. And if that happens, then we will we'll return the L and right. So the L will be here and the R will be somewhere here. Then if we get a substring, we will return this whole string. But we don't want to get these because they're useless inside. They're not used, so we should skip those letters and only look at the ones that look at the actual ending that has an alphabet. So the previous value stores the actual left index that actually has an alphabet, and the temporary value also stores the same but on the right index. So this way we can get the actual distance between them, and so this will be the length of our total palindrome. So it will be this, and then so then later on we can use a substring to get a substring of this length. And also, this will be our start of the substring. So we should start substring, you add this letter and go all the way to this to the distance. So we've already checked the case if we think of our current letter SI as the center of this palindrome. So now we can try thinking SI as the left center of the palindrome and R and SI plus 1 as the right center of the palindrome. So that will be the case if we have an odd number of letters inside the palindrome here. We would set this as our left and this as our right. So here, still the same thing. But here we should start our C as 0 because we're not considering any letters yet. Here we set C to 1 because we're thinking of the letter SI as the palindrome itself already. So we're extending outward from that. But here we don't have anything that's actual center because here there's no actual, there's actually no center here, so the length should be 0 at first. And then we still do the same thing, store the previous value and the temporary value, and just keep on going until you reach the end for either L or R. And then also get the lowercase of those two check if they're inside the alphabet range. If they are, check if they're equal, and if they're equal, still do the same thing, increase our total count of the palindrome length. So for this current palindrome, it will have a length of extra 2, and then still change the previous value and the temporary value, decrease L and increase R. Then we would, otherwise, if they're not the same, that means they're still alphabets, but they don't match each other, then we should stop this program, or stop this while loop. Then we would check if they are outside of this alphabet range. If they are, we should look at the next value. So this also goes on like so, and then finally we'll also check if this current length of the current palindrome is greater than our maximum length of the best palindrome that we found so far. If it is better, then we should set our maximum length of the palindrome to this current C, and also set the starting position of this palindrome to the previous value, and the length of this palindrome to the temporary value minus the previous value plus 1. Then finally we can print out the maximum length of the palindrome, and also get the substring of the S from this starting position to the all the way until this length temporary minus previous plus 1. And this is all we have to do. Since we also added the new lines here inside the string, this way when we're reading any extra lines, we will also get the new line as a character, so it will also print out the new line like what I requested here. So if there are new lines included inside the palindrome text, then we should also print out the new lines.